Okay, so first, the scope of the talk. I will be talking about various switches or switch-ish chips and their support in Linux kernel. And these chips allow to do L2, L3, and some of them also various flow-based offloads. These chips can be divided into some groups. So first group is frag switch. The other group is switch chips which are embedded directly in servers. So this can be eventually used to eliminate the top of rack switches and to create some kind of mesh topologies within each individual servers. This is not at the deployment at the moment, but there is a plan for the future to actually embed these chips directly into servers. The other group is SR-IOV, which is the switch there is embedded directly into a network interface card, and these are mainly used for virtualization purposes. And the last group is home routers, which are known for you probably as open WRT devices, some small routers with 4 or 5 port embedded switch in them. So this talk will be about switch chip support in Linux kernel, but not about deployment of custom boards in Linux. So don't be confused with this, please. Okay. Any questions so far? Feel free to interrupt me anytime. Okay.
So you use the word switch.
Yeah.
Kind of in a more broad.
Yes.
Term, like L3 switch or
yes.
router. It's not literally a switch.
Yeah. The terminology is a problem because how would you want to call them differently? It's very if you say switches, that people can probably imagine something like it, but what would you say to name a flow-based ASIC? It's just that's good. That's a good point. Thank you for that. Okay.
More volume, please. Louder.
I try to. Or you can sit. There are free spaces here. All right. So the current state. I named it as Ice Age because it kind of looks like it. There are two groups of vendors which are involved in switch industry, and these the first group is vendors of the chips themselves. That's Broadcom, Intel, Mellanox, and other ones, and they believe they have to somehow protect their intellectual property because I don't know why, but they therefore introduced. Each of them has their own SDK, like software development kit, but it is a user-space binary blob which is used to access the hardware and provide some API. The problem is that every vendor provides different API, so that introduces vendor lock-in for appliance vendors. Which are the other group? The appliance vendors. They are vendors who make boxes, like Cisco, Juniper, Brocade, and so on. They buy chips from other and integrate them into their custom boards. And they use proprietary tools for the manipulation of the switch chip because of the existence of the SDK, they have to use the SDK from the vendor X and build some management software on top of that. So there is vendor that introduces a vendor lock-in for customers, because if you are a customer buying Cisco products, you are locked for the Cisco because they provide kernel in their devices. However, they do not use the kernel for the chip manipulation. As I said, they have their own proprietary tools. So this is, anyone has a laser pointer, please? That's a shame. All right, so this is a picture of the current state. On the right side, you can see the typical infrastructure in Linux regarding the network interface cards. You can see the user space part is on the top, in the middle is the kernel, and the hardware is on the very bottom. So now, here you can see network interface card, which has a driver for that in kernel, and it creates an instance of network device, which is somehow related to the physical port. And after that, you can use utilities like IP, TC, bridge, and so on. Network manager, of course. Via standard interfaces to somehow configure it and manipulate the network interface card hardware. On the other hand, if you have a switch chip, you do not have any kernel part. It is the user space directly accesses the hardware via some awkward stuff, but it's not that the kernel actually does the thing. It actually only allows the user space binary blob to access hardware. And there is a proprietary switch application built on top of that SDK. So, is this clear? All right. So, we would like to change that. So, we created some kind of desired model what would be probably good to have to handle switches in Linux kernel. So, we would like to reuse the existing networking tools for switches. We would like to use IP, ETH2, bridge, network manager, open vSwitch, of course. It's a huge deal these days. We would like each switch port to be represented as a single network interface. I mean network device. So like ETH0, ETH1, it's for 2 ports, for example. We would like to allow the switch port to work as an independent network interface card. So you can assign IP address to it, you can transmit, receive packets, and so on. And you can also do routing in between the ports as you would within 2 separate network interface cards. So we would like the same functionality here. And also, we would like to make the port devices work in layered topologies. These layered devices are, for example, bridge, bonding, open vSwitch, so on. And there is a desire to, if it's possible, to offload the functionality to hardware. So if for example, the switch chip supports L2 offloading, L2 forwarding, which probably it would, we would like to, if you set up the bridge on top of the ports, you would like the hardware to do the forwarding for us. So the packets don't actually come to kernel if we do not want to. Okay. Yes. We would like also to implement ETH2 API. This ETH2 API will probably change in the future, but still, since we have it, we would like to switch to implement it. So a user can access informations about speed, the duplex, media type, and so on. And also there is a need to provide a way to find out if two ports are actually if two ports are actually part of the same switch chip. And the working name for this model is switchdef. So I will be talking when I'm talking about switchdef, I'm talking about this model. But
aren't there these chips like which don't allow communication with each port?
okay.
Just provide an interface with the Linux kernel to which you can route some ports or just one port. So you can access every port at the same time.
Okay.
You can route it to the Linux kernel CPU.
Okay.
And they like switching inside of them just like you access some of the ports. Do you plan to support these?
You mean like DSA or? I think you are talking about DSA.
I was working with continuum switches, and I heard there was something like that, like continuum chips.
Yeah, we can talk about it after the presentation, if it's okay for you. Any other questions? All right. So here is a picture for the desired model. So here you can see on the right side, that's the same sub-picture as on the previous picture. That's for the network interface card, classical. And on the left side now we can see the switch chip, which has now driver in kernel, and also it has for each port, it has separate instance, which is called SWVP0, for example. It can be called ETH1 if it helps. And you see that it is the driver provides, or you can access the driver in standard way via ETH2 and root netlink as ordinary NIC driver. So this is actually what we want the infrastructure to look like. Okay. The in-kernel switchdef infrastructure can be pictured in this picture. You can see on the left side. You can see down. If userspace calls, for example, root netlink, it will be propagated to the switchdef infrastructure and down to the network device operation. And after that, some action in the driver will be executed, and it will be handled either in the driver, or it can be forwarded to the hardware and handled there. So these are switch-specific NDOs, and on the right side you can see the propagation of event back to, for example, userspace or Open vSwitch code or Ethernet bridge. When some event happens in hardware, it will be handled by driver, and it will be called propagated to this to the code which registers the notifier and handles the event. Okay. Yeah. I think it's clear. So, okay. So what we have now merged into upstream kernel is L2 forwarding offload. It is for Linux Bridge. The pack set includes also Rocker switch driver. Rocker is a switch which is emulated in QEMU, and it is based on OFDPA model, which is proprietary Broadcom model for flows, and we used it to actually typing purposes. It has no real. You do not have. You do not see the real benefit in using it for some use case, but it's only for testing. There are two new NDOs introduced. The first operation is for getting the ID of a parent, and the second one is called to notify the switch driver and hardware of a change in SDP state of a bridge port. And also there are two notifier events introduced, and it's for FDB adding and deleting. So these events are raised by switch driver in case a new FDB entry is added in the hardware or removed. Okay. So future plans. We have planned to support L3 offload, and there was an attempt by my colleague Scott Feldman, and he tried to introduce the support by introducing two new network device operations. First is for adding entry, and the second is for deleting that. And this was not accepted at the moment. There are some demands to support VRF, like the multiple tables for IPv4. There was a patch set yesterday to include this support, but it was not yet accepted. Another thing which we plan for future is flow-based forwarding offload. And there was an attempt by John Fasterband from Intel. He called it Flow API, and it introduces a new generic netlink interface. The problem is that this new interface should be used only for manipulating hardware flows. So if you want to, for example, use it with Open vSwitch, you would have to insert the flows into Open vSwitch in one way, and use this interface to actually do the offloading and insert the switches, the flows into the hardware switch. So that is a problematic. The nice thing of this API is that userspace application can query the hardware for the capabilities, and so it can see how many tables it supports, how big it can be, what actions it supports, and so on. And it can adjust the flows to insert the ones which are supported by the hardware. So this is nice. So another approach for the flow offloading is to use TC, which is well known and used for a decade, more than a decade. And the proposal extends the existing TC Netlink API for the flows, and it provides. It is after that possible to use the same API for both software and hardware data path. So I will show you how it works on the next picture. So this is what I was talking about, the TC-based offload API. You can see something similar to what you saw on the previous pictures. So here you have a switch driver. Also, you can see the port representers. And now there is an Open vSwitch bridge, and these 3 ports are included in that Open vSwitch bridge. On the top, you can see DC subsystem, which can be divided into 2 main parts: filters and actions. And the proposal is to introduce new filter called xflows and new action called xflows as well. And these 2 will serve as a front end from the user space to actually manipulate with the flows. And each consumer can implement the backend for the xflow. So here you can see the backend implementation in Open vSwitch and in some specific switch driver. And after that, on the top, you can see either Open vSwitch user space or custom flow managing application, and they both use the xflows interface to manipulate the flows in both Open vSwitch data path, which is in software, and the hardware as well. So this is clear as well? Or any questions for that? Okay. There is a specific use case, which is for SR-IOVs. There is an embedded switch in SR-IOV capable NIC. In every NIC, there is an embedded switch which interconnects virtual functions and physical function. The capabilities of the embedded switches differ a lot, and vendors try to support more and more in that. So I was talking with the Mellanox guy 2 months ago, and he was talking about supporting flow-based forwarding directly in the embedded switch. So eventually, it would be possible to offload Open vSwitch functionality into the embedded switch. We'll see how it will work. From the Linux kernel perspective, these embedded switch should be handled as any other ordinary switch chip. And of course, the purpose of the switch dev, the desired model, is to provide this kind of abstraction. There is a lot of potential for virtualization purposes for SR-IOV. As I said, Open vSwitch acceleration is one, and that can be used in containers and OpenStack and so on. So I will show it on next picture. So here is only kernel and hardware. User space is not here at all. It's not needed. You can see 2 drivers. One driver is for the VFs and PF themselves, like for the network interface card part of the SR-IOV card. And there is a separate driver for the embedded switch. And here in the SR-IOV NIC, you can see the embedded switch and the representers for the internal port are handled by the embedded switch driver. So here you can imagine that the VFs, this is a single machine. Here you can imagine a typical use case for virtualization is that you put the VFs into separate virtual machines. So after that, you will have the driver instance not here, but in the virtual machine. And when you put on the bare metal, when you put these representatives into Open vSwitch, you can after that, which is how it's done in OpenStack and in containers as well, like in Kubernetes, for example. You can then use the offload for communication of virtual machines out to the outer network and with each other. So this is a pretty interesting use case. Okay, so this is all. If you have any questions, feel free to ask. Okay.
Maybe you can give some information about if there's any chance to somehow make this work with the Trident, or is there any hardware at all that is like one new thing that can support this sort of thing locally today?
You mean Broadcom Trident?
Or something like all the ASICs are super proprietary and it makes it hard to do on real hardware?
Yeah.
How can you save us from this?
Yeah, that is the point for us, to actually provide the infrastructure so the vendors can adopt it and provide their own drivers. But they have the SDKs, and they are quite happy with that for some, because they provide therefore they have a vendor lock-in, and they are happy. But we are not happy in putting that in RHEL, for example. Right. There's no go. So this goes in little steps. We see for past year, I see a change of hearts in this for the vendors, but it will be slow. But it will eventually happen. I'm pretty sure of that. It's just a matter of time. Okay, good.
What about Facebook and their own compute platform? They're working on network switches too. Don't they have interest in that part?
Yeah, that is something a bit different because they are more of the open hardware, and they also use these ONI, like it is a bootloader, I think, and they do not care that lot about open source drivers and kernel drivers. They are quite happy with the SDKs the vendors provide. So this is not. It is somehow related with this, but not that much. They have these SDKs and they are quite happy with that. So. Yeah.
Because they could push because they have the volume. So.
Yeah, sure. We try to stay in touch with them and to contact them every once in a while. But I don't know. I do not see the enthusiasm from their side. Yeah, we'll see. Maybe it will change. Okay.
I have two questions.
Go ahead.
The first one is how far we are from stable product with Open Switch. The second one is how far we are compared to NSX or Zira version of Open Switch.
Okay, so the answer to the first question is that for the SR-IOV use case, that is probably the thing which is the most interesting. There is a problem that so far SR-IOV vendors do not provide the driver for their embedded NIC. Embedded switch. So, but the infrastructure is there somehow in Linux kernel. Not the flows, but flows will get there, I believe, in a month or something like that. And after that, it is just up to the vendors to provide the drivers. But I have some indications that they want to do it, and they have no other choice, because if they want to support it, they have to have open source driver in kernel, in RHEL, for example, or they have to have it in tree to support it. So they will eventually have to adopt it. So this looks good, I think. Yeah, it will happen in half a year or something like that, when it will be supported, the use case you are talking about. The second question was about what?
How far we are as OpenSwitch from the NIC era version of OpenSwitch?
Well,
or NSX?
well, I don't know how they exactly handle this. Maybe they are using SDKs as well. I'm not sure. I didn't look into that, so. Okay. Any other question? Huh? Okay.
Since I'm here, another question that just came up from my mind. From your point of view, there is a way to have, for example, a trunk in the OpenSwitch and forward it to a VM, virtual machine, because at the moment there is no way. For example, I speak about OpenStack because this is my environment.
Mm-hmm.
And there are cases where someone wants the virtual machine, want to enter the whole trunk and back inside the virtual machine, the traffic. From your point of view, there is a way to do that?
Well, that is not much related to the offloading. That is just the functionality of OpenSwitch itself, right? So we can talk about it after this.
Yeah, I will look at it.
So OpenSwitch provided transport to the rest by validated. So it is just a question of is out about it, not supporting. So it's possible.
Any other question? Okay. Thank you.
Yes, I'm the next.
Okay, we will show you. Yeah, we will show you the time signs. If you are running out of time, we will show you 10 minutes before, 5 minutes, and you are out of time. We'll show you 3 times.
What will you do for that? Will it just be like 10, 5?
We have the signs written
Oh,
on the
okay,
paper
awesome.
over there. And yeah, I'll introduce you. And we are good to go. So we started 10:40, I believe.
Yep.
Okay.
Yeah, I just want to get this stuff set up and see
Right,
how big
right.
the nodes and
There's
stuff
only VGM, I'm afraid.
are. Yeah, that's fine. That's all I got.
Okay. There's water if you want.
Yeah, thanks.
Ty kam?
Začne se na USB.
Tady, jo. Já jsem to právě tady vysvětloval, že to opravdu nejde a
Is there like clicker
říkali, že
mouse,
ať to vyzkouší.
anything like that?
I'm afraid not.
Já jsem nechápu, já jsem říkal, že není nikam zapojit. Nahrál tam tu prezentaci?
Ne.
Tak ho pak budeme muset najít a nechat to tam.
Pošleme mu e-mail. Ale môžeš to povedať kolegovi.
Co? Ale nechal ten 2 minuty. Ano, tam to bylo na internetu. To nezavřel. Just please copy your presentation of the flash drive. Thanks.
Tady to myslím, mali bychom s tím mikrofonem
Jo.
když jsme se nedostali na světlo.
Já jsem už tady stopil
Já nevím, já si tady nemůžu ty popočíky, protože učitelům a pokud se neslyší, zvedne si
no, tak to půjde vidět na
ale jako
jako zkoušeli jsme záznam, je to perfektní, tam to jde všechny hodně. Jo, tam to je jsme to zkoušeli, funguje to dobře. Akorát prostě tady v místnosti mají problém tam vzadu třeba slyšeli.
takové se nesmí bavit. Přednášející se předpokládali, zvládá nějaký hlasový form. Já si pamatuju, že bych byl ten mikrofon jiný.
Tak zvládalo se to, ano, zvládalo se to. Ale když tak to bude mít tak si můžeme a hlavně něco lidi počítají. Nevím, já jsem dal auto, on se to nastavil.
Mně jde o to, abych si na tom rozlišení vyzkoušel tu přednášku.
No, ty projekt, který ideálně byl úplně zvládnutý jiný rozlišení, ale ideálně je, když se
No, there is no way how to plug the microphone to the system, so you just have to be quiet in the audience and the speaker just has to speak louder, so
then you have to yell. Hi, my name is...
yeah,
I'll
probably.
try. If I'm not loud enough back there. Oh, so you take a picture? Okay. Yeah, if you
A ten záznam, jak funguje dobře, tam to slyšet fakt perfektně v pohodě, takže tam není a i myslím, když byl tam, tak protože jsme úplně na rohu, tak už šlo nějak rozumně slyšet na ten záznam. Jasně. Já právě taky nemám větší problém, že musím se spíš vydat, abych mluvil pošušení.
Když to postavili, asi 2002, a to se zrušilo.
Tam se dodělávali. Já jenom protože si mě lidi na to ptají, tak jak mě já jsem nevěděl, jestli tady je tady hlavicí a tam jsem věděl, že se to mělo dodělávat a v Dčku by mi to už dávno bylo. Já jsem to studoval. Nešel jsem na vypínač, tak jsem nevěděl.
No, oni tam stáli jako.
Já vím, no, budu jenom se říct zarazit, že jsem nešel podívat. Já si říkám, že jsem to
Já jsem
stejně postavená.